Hello, and welcome to today's webinar on electrical safety, brought to you by Plant Services and Fluke. I'm Tom Will, Chief Editor of Plant Services, and I'd like to thank you for joining us today. This webinar is sponsored by Fluke. Founded in 1948, Fluke Corporation is the world leader in compact professional electronic test tools. Fluke customers are technicians, engineers, electricians, and metrologists who install, troubleshoot, and manage the industrial, electrical, and electronic equipment and calibration processes. This is also the third of three 2017 webinars, which feature original research conducted by Plant Services editors on topics that our readers tell us they want to know more about. I hope you enjoyed this presentation, and I also encourage you to check out previous research-based webinars from this year. One of them is on predictive maintenance, and the other is on workforce, and they are both available on plantservices.com. Now, before we get into the main presentations, there's a few housekeeping issues I'd like to review with you. On your screen, you should see several primary sections. The upper left, or audio section, allows you to adjust the volume of this presentation. Just hover over this section with your cursor until you see the audio line control and adjust it to your preference. At right, in the largest section, is where today's presentation slides will be displayed. Under that slide window, you'll see a group chat section where you can chat live with fellow audience members. To the left of the slide window is the Ask a Question box, where you can type questions for the presenters anytime during today's webinar. We'll get to those questions during a live Q&A session following the second presentation. I also want to call your attention to a handout section at the bottom left, which contains links to several resources, including both sets of presenter slides from today, a PDF download of the preliminary data set from our 2017 Electrical Safety Survey, and this is exclusive to live attendees today, and 7 links to downloadable assets from Fluke, including the white paper 10 Dumb Things That Smart People Do When Testing Electricity, and the application note Detecting Electrical Unbalance and Overloads. Finally, at the bottom of your screen, you should see icons for additional features. By hovering over each icon, information about that icon will be displayed. If you're having technical problems, you can type in your question or concern in the Ask a Question box, and one of our technical engineers will assist you. If you need a better view, especially of the data slides that I'll be reviewing, which have some small type and small numbers, you can enlarge any section by clicking on the box in the top right corner of the section next to the X. If you accidentally close out a section, you can get it back by clicking the Restore icon at the bottom of your screen. It's the leftmost icon in the shape of a double arrow in a circle. This webinar will be archived, and we encourage you to direct coworkers to the recorded presentation. Finally, at the end of the presentation, we'll ask you to complete a very brief survey to provide feedback that we use to improve these webinars. At this point, I'd like to move into the presentation part of this webinar. In a few minutes, we'll be joined by Corey Glassman from Fluke, who will present on electrical measurement safety, built-in safety test tools. However, before Corey presents, I'd like to review with you several key findings so far from the Plant Services 2017 Electrical Safety Survey. This survey was only launched about a week ago, and already we have close to 100 responses, which is really great. I want to thank anybody on the call today who already participated in the survey. I'll have the survey link at the end of my slide deck, and this survey will be open until the end of November, so there's plenty of time for you to take it and to let your colleagues know if they would also like to contribute. The first slide I want to go over is that OSHA just released their top 10 violations for fiscal 2017, and just want to point out that 5 of those 10 have to do with electrical safety. No surprise to any, I'm sorry, 4 of those 10. There's 4 highlighted in red there. That should be really no surprise to anyone on this call. I know everyone here is focused on making your workplace electrically safe. This webinar is, again, the third in a series of 3 that Plant Services has done this year. And all I want to do is call attention to the previous results if you have interest in our February story on the workforce, where everyone told us that what they're most concerned about is recruiting talent. And also the April story, where people told us how they're using predictive maintenance tools and everything from electrical systems to rotational equipment. The cover story on the Electrical Safety Survey will appear early next year. It's currently scheduled for one in the February issue. The survey is still open, as I said. There's only 30 questions in 5 categories that take about 10 minutes to take. So without further delay, we'll get right into the first category, which was background information about the survey respondents. This slide details the various job titles of our survey takers so far. About 50% of them work in the maintenance function, about 15% in the reliability function, and about 45% of the respondents are engineers, which is great. The next set of data cover generational fit and electrical experience. And boy, we do have a lot of experience coming out in the survey. All close to 80% of the respondents to date have more than 15 years of experience in this field. And about 60% of the respondents would characterize themselves as baby boomers. I do want to note that every time we take a survey like this, the number of people who report themselves as millennials and Generation Y are growing. For the PDM survey back in April, we had about 9.5% response. For the workforce survey, we had about just under 9%, and they're up to 12.2. So it's great to get that wide diversity of perspectives on these surveys, especially considering there's so many people from Generation Y and the millennial generation currently in the job with everybody. Finally, I wanted to point out we asked a question about certifications. We ran through level 1, 2, and 3 thermography. We asked if you had your CMRP. And most of you told us that you were state licensed journeyman or higher, close to 16% to date. And I think what also jumps out is that at this point, half the respondents mentioned that they did not have a certification. So if there's an area that you're interested in, it's always worth talking with your supervisor or your employer about what it would take to start getting certified and what value that would add to the company. Now we'll launch into the primary question. And to me, this is sort of the core question that set the tone for the survey, which is, do you consider your plant electrically up to code? Essentially, is your plant electrically safe? Corey and I were talking before we went live on the webinar today, and he and I sort of agreed that this fit the 80-20 rule, which is about 80% of the plants will be safe, and 20% are currently either working through issues or have had issues in the past. So this data point didn't jump out as out of line with the industry. The next two data points cover whether people have been involved in OSHA investigations and whether the facility engages in near miss reporting. And again, we're happy to see these numbers. This points toward a general strong culture of safety out there. And this last question, what is your facility's average time between electrical incidents, also reinforces those data points that we just saw. Nearly half reported they'd gone more than a year without an incident, and about 75% reported that they'd gone more than 180 days without an incident. Finally, we asked people, please rate the following electrical safety challenges at your facility. And I know the type is fairly small here, but I do want to point out that the highest number of people who said that there was a high issue was related to poor and ineffective equipment grounding, which is interesting. Almost 46% said it wasn't a factor at all, but almost 10% said yes, that's exactly what we're seeing. That's the problem that we're having. And I do want to point out that if you look more towards the middle, people who reported the most problems, not necessarily high problems, but low to medium, we're having issues with loose electrical connections, splits, trips, and faults. Now, I know Corey's going to have some thoughts on this because he has seen the whole data set. Some questions that we asked, we are reporting it, such as how many of you use portable IR cameras, and also how many of you use IR windows on panels. This question especially seems to point to the fact that those who are using those tools are finding these kind of problems, that IR cameras most quickly pick up those sort of loose connections and grounding issues. And I'm going to invite Corey to speak in a few more questions here when we get to questions on energized work, because he had some really good thoughts on what he's seeing. So the third section of the survey covers technology. And this one was, are you using wearable safety systems and sensors? what we were really probing for in this set of questions is to what degree are new technologies, especially internet-connected technologies, mobile technologies, wearable technologies, impacting the workforce. So you can sort of use these data right now to benchmark where you and your facility are. Half told us when it comes to wearables, no with no plans to change. And I think that no plans to change is interesting because if you look down in the green pie area, about 10% said no, but plans are in place. Half the respondents said no, and there's no plans to change in the future. And I think one of the logical follow-up questions is this an insurance issue where it might not be feasible to deploy wearables for reasons of data privacy or data policy? This next slide differentiates between are you using IoT technologies to monitor your systems versus reporting on the health of those systems. And you see fairly similar numbers, but I think it's notable that you get a slightly higher set of data when it comes to reporting on the health of your systems, in that people are using the internet. This points out something which I've been seeing with plant teams, which is that one of the first ways into internet-connected equipment and tools is to facilitate easier reporting. Again, those numbers aren't too much higher than the monitoring numbers are, but it does fit what we're seeing, and it's also gratifying to see these numbers line up so well, which is that when either people are deploying both at the same time or they're seeing value in the one, the reporting, and then pursuing the other, which is monitoring. Okay, energized work in ArcFlash. I'll read off this question. How much of your work is energized? 1/3 of you said 0 to 2%, and additional, it looks like more than 10% of the work was reported energized by about 26% of you. Corey and I, again, we're talking before this about what we're seeing, and Corey maybe can step in and explain sort of some of the thoughts behind the numbers that you're seeing with this question and with the question on IR windows and IR tools.
Sure. Hello, everyone. When you're trying to look for a problem, especially with loose connections inside an active panel, you want to stay out of the sort of away from the loaded cannon and away from the arc flash zone. So one easy way to do that is to activate the panel but have an IR window installed so that you're able to use a thermal camera to detect any hotspots in any conductors or connections that you happen to see. Obviously, a hotspot's going to happen if you have excessive resistance with a loose connection because the current increases and that creates heat. So this definitely represents that a lot of work is done in front of that arc flash zone or in an active panel. And ultimately, you want to use tools and techniques that keep you away from those active conductors as much as possible.
All right. Thanks, Corey. And I know that Corey's presentation dives more deeply into those kinds of tools and technologies, but it is worth noting that when we asked a question on the technologies people are using, only 1/3 reported they were using IR windows. And that data point is part of the larger data set, which again is in the handouts area. If you'd like to download those results and look for yourself. Moving on in this section, a couple of questions on ArcFlash energized work. Does your facility have a policy in place on energized work? Again, 80-20 rule. If yes, how do you communicate this policy? And again, the vast majority of energized work policies communicated through training, which is great. We have some training questions to wrap up this presentation with. Finally, 3 questions on ArcFlash itself. Have you been trained specifically for ArcFlash? The 80-20 rule applies here as well. 80% yes, 20% no. Have you ever been involved in an ArcFlash incident? Nearly 30% said that they have, interestingly. And have you done an ArcFlash study on your gear? Only about 60% had done the ArcFlash study on their gear. There's more information, again, in the PDF download about kinds of equipment, especially ArcFlash gear people are using. Last arc flash question is, do you know someone who's been involved in an arc flash incident? And I'm assuming that people didn't include themselves, but they might have. The good news is that 40% said no. The bad news is that 60% said at least one person, and 26% said 2 or more people. Finally, the last couple of questions to wrap up this part of the presentation. The training category. How often are workers at your facility required to take electrical safety training? And you're seeing, I think, the industry standard. About half of you said report to annual training. 11% more do it more than quarterly. But if you look at the pie slices at the upper left, never 5+ years and 2 to 5 years. If that's sort of what your facility is engaging in, that frequency, it might be a good idea to check in with your management and see about increased training opportunities. Finally, the last question on this survey is, what training methods does your facility use? And what we were really trying to tap into here was, to what degree are digital technologies like simulators and augmented reality starting to have an effect? And if you look at this box here, half, you see 80% using on-site training. With the next 3 items, offline courses, online courses, and online webinars, it's a tale of 2 plans. Either are or you aren't, 50-50. And then finally, when it comes to advanced technologies, at this point, people are telling us in the survey that they don't see any plans in the future. I personally believe it's going to change over the course of several years as it gets more cost-effective to create simulators and augmented reality, but we'll see how that goes. So I'm going to wrap up here and turn it over to Corey in a second, but I also want to encourage you to take the survey if you haven't taken it already. This link will be part of the downloadable slide deck from my slides. The survey will be open until November. Someone asked a question, he asked a question box already, how many have taken the survey? So far, close to 100 have taken the survey. We're not going to close it out until we get plenty more than that, though. And we're going to do the full cover story on the survey early in 2018. So with that, I'm going to advance to the cover slide for Corey. And before I turn it over to him, Corey, let me go ahead and introduce you. Corey Glassman is Global Training and Curriculum Development Manager for Fluke Corporation. Corey is past president and board chairman for ATMC, is ASE certified, and has worked in the automotive industry since 1974. Since joining Fluke in 1990, Corey has served as the automotive program manager, responsible for many product introductions, including the Fluke 87, the Fluke 88, and the Fluke 98 automotive scope meter. Corey also is ASNT certified level 1 in vibration analysis and level 2 in thermography, and served in the U.S. Air Force as a tactical air command instructor. Corey, welcome to the presentation, and thanks for being with us today.
Thank you, Tom. Thanks for the nice introduction, and welcome everyone. In today's presentation, I want to pay careful attention to the words on the title slide. Electrical measurement safety. It's fairly clear by the survey that everyone took that people are fairly well skilled in NFPA 70E, which is enforced by OSHA clearly, and that they have a lot of the fundamental understanding of what can cause an arc flash or arc blast. And today's presentation is actually in 2 separate parts, primarily primarily in 2 different areas. One where I'll cover the NFPA, which is a little bit of the risks in the electrical environment and some of the common errors that can be made that could possibly trigger an arc flash and arc blast incident. And the fact that, well, test instruments are part of PPE. And as a matter of fact, they're in the NFPA 70E, the 2015, and the new requirements that are just now coming up at the end of the year. And then a little bit about CAT ratings. So we'll talk about what happens in an electrical environment and what could possibly cause an arcing incident inside our products, inside the test equipment that you do have, and how to rate that equipment, how to analyze the equipment, we'll take a look at some of the protection that manufacturers build into the equipment to help keep you safe when using it. And then also the fluke tools that we have that are designed for electrical test, and then what next steps that you can take. And please, during the presentation, ask questions. Feel free to raise some of these issues. We have some people that are here that can answer those. I can answer the majority of those, and that's what makes this very interactive and great. Industry estimates, 5 to 10 arc flash incidents occur every day in the U.S. Now this came from a survey that was done originally compiled by a company, Capshell, incorporated in Chicago. And this was done probably about 8 to 10 years ago. So that number has grown significantly. And an arc flash can happen from a short between phases, a short circuit between phases, or even phase to ground. And it can happen even in a residential panel as well as commercial or any other source that you may have. So the amount of incident energy and the amount of current, obviously upstream from the circuit protection before clearing happens, will govern how long this arc flash stays in effect. And 77% of the recorded electrical injuries were due to arc flash incidents. And we'll cover a little bit about PPE. You're familiar with PPE and the 4 categories of the ratings for the therm, the counts on the arc flash, the gear that you wear. But that, in some incidents, will not keep the arc blast, the molten metal, away from doing harm and doing injury to someone. So that's where we need to be very, very careful. And every year, more than 2,000 people are admitted to burn centers with severe arc flash burns. It does happen. Risks from electrocution and shock hazards. We all know that this exists. And what I found interesting is cardiac arrest can occur, and that's at the bottom of the chart here, when you reach over 2,000 milliamps, which isn't a lot of current. As a matter of fact, a standard light that you plug into your electrical outlet at home, just a little night light, actually conducts or actually uses more current than that. And so a very small amount of current will actually cause a great deal of harm. They even have what they call the let go. So at 6 to 16 milliamps, partial shock and muscular control freezes. So when you exceed just 16 milliamps of current through the body, you're unable to let go of the surface. And so that's why in electrical safety, we teach people, if there's an electrocution taking place, don't grab a hold of them to pull them away from the circuit. Definitely use something non-conductive or body block them to release them from an active circuit. Otherwise, you become part of that. The risk from an arc flash. It is created from the phase-to-phase or phase-to-ground short circuit. What happens is the current passes through air, ionized air, which is plasma, becomes a very good conductor. And once the arc begins, it feeds off any matter that's in its path and it vaporizes it. So you have the bus bars, all of the different conductors, the conductive core of any of the wiring, everything is virtually liquefied. And it takes place, I say, under a second. It's actually in milliseconds. So the blink of an eye, the arc flash incident and the arc blast is really over. But the damage lasts a lifetime. Just the shock of it happening and the injuries that can be sustained are enormous. So this is where we need to be very careful, and most of these are definitely avoidable. And this is a little bit of the discussion today, is how can we stay safe and how do we keep from having these occur. So there's the risk from the arc blast. So the arc flash is what initiates this. That's that short circuit. But what happens is the real effect takes place when you have the explosive result of the arcing fault. 740 miles an hour. This is propelled towards the body, as well as in the decibel range that it will rupture eardrums. All of this happens just instantaneous. And you are trying to make sense of all of this at the time when it's happening. So afterwards, there's a lot of, obviously a lot of damage that takes place, but blinding light, toxic smoke, everything takes place in a matter of a moment. There's some causes of the likely causes that we've seen that cause the incidents. And I'll just go through them. The racking of a circuit breaker, especially a live circuit breaker, or inserting or removing the breaker on a live bus. The loose panel wiring. The loose conductor, it can short across another conductor or to ground. And in some cases, just opening the panel or gaining access to the conductors can disrupt that and fall down and short against another conductor. Removing panel covers. This is also something that we found if you do have a thermal camera. I know Tom talked a little bit about that, and 70% of the people did say that they have thermal cameras and they use those. That's great. You should use them before opening the panel. And again, it's a direct measurement of a surface measurement of temperature. But if you detect excessive temperature, don't open the panel. Go downstream, shut off the lockout, tagout, shut off that panel before opening it, because there's a strong likelihood that there is a degree of arcing or overheating taking place. Hand tool shorted across two phases. This can happen very easily if you're using a hand tool on one phase, again in an active panel, and even if you're wearing the correct PPE, if it shorts against the ground or another phase, you can have that short circuit. I was once on a photo shoot, and I was watching an electrician, an experienced electrician, opening the back of a panel and had his test tool, or his pliers, his lineman's pliers, just on the top of the panel, and when he removed the cover, the pliers fell inside. Obviously, we dived behind some pallets, expecting that something was going to happen. Thank goodness it didn't. But incidents do occur, and when we don't expect them. So using incorrect test probes, and we'll cover a little bit of this. In fact, that's governed in NFPA 70E as far as the exposed metal that's on test probes that should be allowed depending upon which category environment you're working in. Also, the misuse of measurement tools. Misusing a multimeter when you go into current mode, and we'll talk a little bit about this, could put a direct short against a conductor and cause and initiate an arc flash or arc blast incident. Here are some common errors with the measurement tools. So we'll take a look at those. So we have one on the upper section that's measuring some AC current, and then we have some voltage or voltage drop in the lower picture of what can possibly take place. And what ends up happening is connecting a meter to the voltage source with it configured inline amps. You basically have a short circuit that could possibly happen. You have a fuse that typically protects this. And in Fluke's case, this is a very fast blow fuse to separate the instrument from the circuit. But nonetheless, that does put it in a short circuit type of position. And if you go ahead and measure across a voltage source, it will open the fuse. So again, if you have an instrument that has a fuse, don't bypass what the manufacturer's recommendations are for it. Because then you're violating your own safety. The picture in the bottom talks a little bit about measuring ohms, for instance, on continuity on a live circuit. Now, Fluke instruments are rated up to the 1,000 volts. That's considered low voltage in most high-end circuits. But up to 1,000 volts where our measurements are being made, there's internal protection to protect the user against any problems switching between continuity or volts or any other function on the meter except for amps. So those are a couple different areas that you want to watch. You don't want to hook them up incorrectly. And measurement, we dedicate a lot of money, a lot of effort that goes into the test equipment to ensure that they meet these types of requirements. Follow the industry guidelines. That's what they're about. NFPA 70E, it addresses all of the safety practices, the safety equipment, the use of the safety equipment, and the installation requirements that are in place. PPE. There's some fine manufacturers of PPE. Wear the PPE. You know, one thing that we were discussing, and one thing that we noted, when we talk to a lot of electricians, there's an opportunity to grow complacent. Because you have the PPE is fantastic, and it's the right rating of PPE. But many people can grow complacent with making measurements on active panels if they haven't had an incident. And it's that complacency that says, it won't happen to me. I don't need to wear my electrical measurement safety gloves or eye protection or hearing protection, or I'll wear short sleeves without the, the flame resistant long sleeve clothing. And that's when incidents could likely occur. So you definitely, if you have the equipment, I urge you definitely to wear the equipment. And remember that a lot of the people that follow us into the career path, a lot of the younger people, they're looking at us. They're watching us to see how we perform our task, how we perform this job. And if they see that we're not wearing PPE, they feel that that's okay. And really it isn't. Always wear the PPE that's rated for the environment. There are some safe distances, some flash limits of approach, and these are the boundaries between the active conductor. And you can see here where you have an exposed conductor, and that becomes the restricted space. And then you have some limited space, and then you also have some additional with the arc flash boundary. All of these are spelled out in NFPA 70E as far as a qualified worker. And if you do enter into an area, what type of PPE you need to wear based on incident energy. And what you find after running some of the calculations, depending if it's a dual-fed panel, depending upon the total current coming into that panel, is that you might come into virtually an auditorium and find with an open exposed panel, anyone entering that area needs to wear arc clothing. You may find that that is a larger area than what you had first thought of. And I once had an electrician tell me it's very similar to standing before a loaded cannon when you're working on these panels. So I urge you definitely wear the correct PPE and follow the safe procedures. As I mentioned before, in NFPA 70E, Article 110.4, test instruments are part of the PPE, and part of this is that they shall be rated for the circuits and equipment to where they'll be connected. They'll be designed for the equipment and the environment where they're being used, and that's what we're going to talk about next, and how you can be sure you're using the right equipment. And also, they'll be visually inspected. In many cases, I've seen where you come on the job site and your meter may be broken, you may have forgotten it, something may have happened to it, so you borrow someone else's piece of test gear. You want to be able to be qualified to understand the operation of the test gear and also how to inspect to make sure that it's fully operational. If you're doing a dead live test on an active conductor after you have performed a lockout tagout, you want to make sure that you're using a piece of test gear that gives you the correct results and you can interpret those as working then in a safe environment. We'll talk a little bit about that. Also, the installation of the protective tools, including voltage test indicators, shall be verified by test inspection. And that's part of NFPA 70E. So I do urge you to definitely get a copy of NFPA, read it, understand that, follow through with whatever piece of test gear you have, that manufacturer's recommendations for training on that equipment. Be fully capable. Live dead live testing. I just talked a little bit about that, and that's verifying the operation of the voltage tester, whatever you're using to measure for active voltage on that circuit. And this is, it's actually fairly simple to understand, but before taking that test, and this is spelled out in NFPA 70E, you want to be wearing the proper PPE for the category, wherever that panel or wherever that conductor or wherever that measurement is to be made. And you want to make sure that it's AC or DC, because now we have backup power supplies, we have a lot of DC generators, backup systems, batteries. So again, it is spelled out what type of PPE to wear. And then you want to be able to lock out, tag out, but then when you open the panel while wearing the PPE, test the active conductor. But before testing the active conductor, you need to make sure that the test equipment works. So you need to measure on an active source and make sure the test equipment is being able to read that, then measure on the unknown, and then verify operation on the other source. And that cuts out all concern that conductor is or is not active. And we'll talk a little bit about that. In this case, we do have what's called a proving unit. And what you're seeing here, where the measurement is being made, is a regulated 240 volt supply, both AC and DC. So you set your test instrument to the volts, either AC or DC. Press in these recessed connectors that are on this proving unit, and your instrument should read the 240 volts. Then make a measurement on the unknown, and then make the validation on the proving unit once again. One of the problems that we've seen is if you use lockout, tagout, and you cut power to a panel in a maintenance room or a machine room, and once you've cut power to that room, typically they don't have an electrical receptacle that is accessible to make a proving type of measurement. And so this is a portable supply that you can take with you to validate the operation of your test equipment. And whichever means you use, definitely follow that. They're also making a recommendation in NFPA 70E as a direct contact with the active conductor to measure the available voltage. Bottom line, safety first. So whenever possible, work on de-energized circuits, but that's not always possible. And again, problems show up on an active panel. But follow proper lockout, tagout procedures. Make sure everyone is briefed. Don't work alone. Work with other people. Make sure you go over the plan, the work, and then work the plan. Use well-maintained tools, appropriate personal protective equipment. We've talked about that, and that deals with all of your PPE, all of your equipment that you're going to use. Verify that they're in proper working order. Practice the safe measurement techniques. So we've learned always connect the grounded lead first, and then the hot second, and then disconnect the hot lead first, and then the grounded lead second. As a matter of fact, you'll see on a lot of our test leads, we have right angle connectors, and the right angle connector on a test lead goes on the instrument side. The reason it does is so if you move your test equipment out of range of the length of the test leads, that they don't unplug from the tester connected to an active source and create an arc flash or a grounding incident. So understanding how to connect the test leads to your instrument and to the panel, very important. And use the live, dead live test method. again, very important. Ensure that your test equipment meets or exceeds industry standards. So we're shifting gears here. That was NFPA 70E. Now we're going to talk a little bit about International Electrotechnical Commission, IEC for short. And there's a standard called IEC 61010. And these are the group standards for the low voltage test measurement control equipment. When we say low voltage, it's 1,000 volts or less. And these are standards that are developed primarily for manufacturers that deal with what's called creepage and clearance inside the instrument. And it's based on the amount of energy that can take place from a type of an arcing incident. And we'll talk a little bit about what happens and what causes that arcing incident and the type of tool to use. So these are environments that are rated in 1,000 volts or less, 480 volt and 600 volt three-phase circuits. Transients. These are almost invisible, but they can have spikes of up to 8,000 volts. Transients can occur from motor switching or inductive loads that are switching off. A good experience from that is a coil discharge. So a transient can be very narrow in its width of the spike, but it rides on the initial voltage and current that comes in. And it can happen from a lightning strike or adjustable speed drives, utility load switching. There's a variety of things that can actually cause a transient to occur. Again, they're invisible. They may last under that 100 milliseconds, but they are extremely dangerous because they can initiate that arc blast instrument or that condition to occur inside the meter. So you want to be able to use the built-in protection in the meter depending upon where you're working to make sure that the transient won't affect you. There are some different measurement category locations. We call them CAT ratings, the industry does. And they're defined by IEC 61010. There are actually 3 separate category locations, and that's the measurement category of where you're actually making the measurement within the facility or within your measurement location. So the first one is considered to be one of the most dangerous because it's the closest to where the initiation of the transient can occur from the service entrance into the Cat 4 environment. So that's where you're closest to the proximity of the incoming power for the utility. So it refers to 3-phase at the utility connection, any outdoor mains conductors, and it offers the greatest amount of protection. But that's also where the greatest amount of energy can actually occur from. If lightning were to strike the power lines and that energy were to come into where you're making the measurement, you need a Cat 4 rated instrument with the greatest amount of protection. Category 3 is the other environment where you have fixed loads, a lot of lighting, fixed loads that are 3-phase. That's considered to be a Category 3 environment. And the reason that it reduces the amount of what we're considering to be the protection in the instrument is that building capacitance and wiring absorbs some of this energy from a transient that occurs, the further downstream that you actually get. So there is a Cat 3 environment, and then finally there is a Cat 2 environment for loads that are plugged in. Again, the greatest amount of danger from transients is really the higher incident areas. So let's take a look at how those are rated and how you can judge your equipment. First, you have the category. So where are you using this? Are you using it outdoors or near the service entrance? Are you using it on 3-phase power? Are you using it on a plugged-in load? Then after that, when you're looking at the rating of an instrument, Are you working on 600 volt or 1,000 volt? There are two different real ratings of that, of 600 or 1,000. So you want to take a look if it's rated in one of those categories. Some meters are actually rated in dual categories. So some might be category 3, 600 volt, and then category 4, or it might be category 3,000 volt, category 4, 600 volt, or something like this, so it's suitable to be used in both locations. Where do I find out about the CAT ratings of an instrument that you may have or that you're considering purchasing? Look at the input jacks of the instrument. You will see where that rating is located. The rating on our instruments, and this is, again, an industry standard of where they're located for consumers, but you could look at the input jacks. You'll see on the left one, category 3, 600 volt. The dual rated ones are the one in the center and the one to the right. We have category 3,000, cat 4, 600. The same thing with the one further on the right. But questions do come up of first of all, what happens if it's underrated, not rated? We'll talk a little bit about that in the next slide, but also read the manufacturer's instructions on using the instrument safely. That is imperative. It's extremely important. You'll also see the ratings, independent ratings on the back of the meter, such as TUV, CE, and these are instrument lab ratings that are independent to the manufacturer that verify that the instrument does in fact meet those CAT ratings. So when you're thinking about buying an instrument, look both at the front and the back of the instrument to make sure that somebody else has verified that what the manufacturer posts on the instrument is in fact correct. Okay, so you have an old piece of equipment. It works fine. It's an older meter, typically before 1997. They didn't have the CAT ratings. So the question becomes, should I replace that? I mean, it still works. Its resolution, its accuracy seems to meet my requirements. Over the years, motors have changed. The amount of current, for instance, that's available to a lot of three-phase circuits has increased substantially. And the meters have to change as well with the spacing between circuit components and the air gaps and spacing inside an instrument. So the recommendation is that they can either be non-rated, such as before that 1997, or they could be underrated for the environment you find yourself in. In either way, you should replace those instruments. Do not use them in that environment because if there is an arcing incident, it could conduct inside an instrument and cause an issue. So you would want to replace those with a correctly rated instrument. Again, we mentioned independent testing and certification. It's listed on the back of the instruments with UL, CSA, TUV. Look on the back of the instrument to make sure that they're marked and suitable for using. There is protection that's designed in. I mentioned the creepage and clearance. We use high energy fuses. We have built-in circuit protection for overload function on all functions, for instance. We devote 10 to 15% of the components exclusively to protection inside the instruments. So make sure that you look into that when you're looking for a piece of equipment, that instrument will protect you. The fuses. The fuses are fairly specially designed fuses for our instruments. They actually have sand, silica inside of them, and they're designed in a situation that opens the fuse to exceed the temperature inside the fuse, which is contained within the fuse, but it actually melts the sand to encase that arcing within glass. And the reason this is important is simply if you have an arcing type of situation, one of the things people may do if they're using test leads is they'll pull away from the from the surface of the bus bar or the connection being made. But what happens then is the arc will continue to jump across that connection. It's sort of like a Jacob's ladder effect that you'll see in electrical. So definitely replace the correct fuse with whatever the manufacturer is recommending. Inspection of the test leads. I put down a few different things to look at when you are working with your test leads. First of all, don't rely solely on the category rating of the instrument. Remember that the test leads are part of the circuit, and so they need to be category rated as well that match the category rating of the circuit that you're measuring. Where there's a wear indicator on a lot of the test leads. Now, for instance, we have test leads, the TL175 is what we're showing here, that have a insulation of, it's done in white, and then there's a separate insulation coating that's done in either the red or black, so that if it's ever nicked or cut, you can easily see that. So on your inspection, make sure you look for test leads that have any damage to the insulation itself. Use shrouded connectors, and the shrouded connectors are important because the conductor inside is recessed. So if it pulls away from the meter or the panel, it won't short out against a ground or another conductor. Finger guards on the meter or on the test lead. You know, we were talking a little bit about this before we got started, and I was talking to Tom, and we were talking a little bit about where do you place your hand on the test probe. Well, they have finger guards to keep your hand away from the active conductor. Test probes, make sure that they're not loose or broken. And I mentioned before that in a Category 3 or category environment, use the 4mm exposed probe tips. We have some test probes that are adjustable or caps that you can put on the test probes to limit the exposed amount of metal when making a measurement, and that will minimize any damage or any type of arcing incident that could take place. This is a close-up of some of that, so you could see where there's some exposed metal on the one on the right in a Category 2 environment where a sleeve actually retracts back into the test probe. That would be 0.75 inches. 0.16 is a Category 4 environment. So minimize the amount of exposed metal in a Category 4 environment. Whether you use whatever type of test lead, you can even put tip guards on. This is innovation at its best. This is a product that's brand new. We're just now introducing to the market, and it's called the T6. In the past, you would need to measure voltage with test leads. With this product, you don't. You can measure both current and voltage and get on the different models, you can get that on the display of the instrument without making an active connection to the conductor. And why this is important is if you're working in a raceway where you have a bundle of wires, in the past, it would be very difficult to get a voltage measurement on that. You could use a perhaps non-contact volt detector to see if one is live or not, and you can use a Rogowski coil, or you can use a current clamp with closed jaws or even open jaw to measure current, but you couldn't get access to the voltage. And in this way, you don't have to pierce the wires, you don't have to do something that's not safe. It keeps you away from that active conductor. Non-contact voltage detectors. So these are small little detectors. They just measure the presence of voltage, and these are great. Now again, non-contact voltage detectors, quick way and an inexpensive way to check for the presence of live voltage, but not the absence of voltage. You want to be careful when you use these. They're really great for electricians looking for an active conductor, determining which is hot. And they light up, some vibrate, some make noises. I mean, I use them all the time. They are great for determining where you have an open in a circuit or where you have a possible problem in an active conductor. wireless tools. We found that wireless tools are now taking center stage. And it's a way to make a connection behind a sealed panel or in a remote location or around a hot object where you can't get close to it, remove the display, or wirelessly connect that instrument. We call it Fluke Connect, where we connect to low-power Bluetooth radio that's built into the product, and it transfers that measurement to your cell phone, and it can also push that measurement up to the cloud. This is really the Internet of Things in work. And I urge you to take a careful look at these types of tools because it gets you out of that arc flash zone. And this is one of the Fluke Connect, which is enabled for that wireless data transfer. And again, with this one, well, you can get 10 of these measurements on the display at the same time, but the different manufacturers have different capabilities. With whatever you do, you don't want to stay close to the arc flash zone. So think of anything you can do to get out of the way. Thermal. We talked a little bit about thermography. I'm excited to hear that 75%, according to the survey, are using thermography. I think we can improve on the numbers of people that are in fact putting in IR ports, which is an infrared port. It's an infrared window. I think I may have a picture of one coming up. And that's something that can be installed during a predictive maintenance or a type of PM where you're looking at a panel, you lock out, tag out, you install the port. It's blast proof. They do have ratings on these ports, but you're allowed to look through the port with the window. Here's where thermography, again, you can analyze that invisible with infrared. So you can see the hot, bright colors indicate excessive current or heat that is actually in any one of those situations. So you can identify some of those conditions that are taking place from a distance. Here's the IR window, and you can see that it's installed. The person is wearing the correct appropriate PPE for the environment, but you don't have to suit up because you're not inside the panel. So you're outside the panel. You just need to wear PPE suitable for the environment. But you can take a look through. Now remember, this is not glass. Glass is reflective to infrared. So this is a special crystalline element that is not reflective to thermal, to IR. Again, test instruments, NFPA states that the employees shall be trained to select appropriate test equipment, demonstrate how it's used, interpret the results, follow NFPA wherever possible. Make sure you understand how to use all of the test equipment that in fact you're using. And finally, one slide on next steps. Okay, you've done all of this. What are some of the next steps you can do? I've included a little scorecard here, and it's in your handouts, but complete some online training courses or a course in electrical measurement safety. Make sure you're familiar with the manual on the equipment, that you're comfortable with it. Work with equipment that's CAT rated for your tool, for your environment where you're working. Audit your test tool inventory. Until you take a firm look at the test tools that you currently have, you don't know whether they're rated for that environment where you've been using them all this time. And then make training and briefings part of your daily work. I think that's very important. Make an active effort to do this. And when you look at your meters, take a look at the accessories, take a look at the meters, look at the crack, if there's any crack cases or any seals or oil leaking from them, defective display. Make sure you look at all of this before using it. And that brings me to the end of my part of the presentation. Tom?
Yeah, thanks, Corey. And thanks everyone who's on the presentation today. I think we're at about time, so I'll move to close out, Corey. First, I do want to mention that Fluke has electrical measurement safety training at fluke.com. So if you want to take a look at some free training resources, go ahead to www.fluke.com and look for electrical measurement safety training.
It's under the training tab, by the way. Sorry.
Oh, no. Good. Yeah, thanks, Corey. I'd like to thank two people who helped contribute to the survey construction, Lowell Wraith and Ian Susser of Interstate Construction. Thanks, guys. And Corey, thank you very much for speaking with us today.
Thank you for inviting me.
All right, and thanks to our sponsor, Fluke. Within 24 hours, we will let you know when this webinar will be available for on-demand viewing. All the handouts will remain available for on-demand viewers except for the preliminary data set from this year's Plant Services Electrical Safety Survey. So if you want to grab those data, grab them now. The full data set will become available once we close out the survey and report the results early next year. Also, be sure to check out the 7 downloadable handouts from Fluke, including the white paper, 10 Dumb Things That Smart People Do for Testing Electricity, and the application note, Detecting Electrical Unbalance and Overloads. Did you like this presentation? Let us know your thoughts by answering a brief survey that will appear on your screen shortly. Again, your candid answers are crucial to helping us craft better future events. Once again, thanks to our sponsor, Fluke. Thanks, Corey, and thanks all of you for attending. Have a great rest of the day.
Thank you.